Assalamualaikum warahmatullahi wabarakatuh, and good morning to all my students. So in this video, we are going to continue our discussion of chapter 9, differentiation, with a subtopic of implicit differentiation. So what's all about this? Implicit differentiation. So let's take a look at the definition here. At the end of this lesson, students are able to solve the first and second derivative implicitly. So, what's the meaning of all this? Implicitly. So, examples, they're given to you a function of 2x squared plus y squared minus y equal to 4, or this one here, where y is not given explicitly as a function of fx, meaning most of the time, we look at a function of y equal to x squared minus 2x, or y equal to 3x cubed minus e to the power of x, where we can divide what we call on the left side of this sign of equal, we can write down as a signal of y, and then on the other side of this equal sign is a function with all the term of x. There is no y left here. But for this case, 2x squared plus y squared minus y equal to 4, we cannot form this in the form of y equal to fx. No, because we got y squared and y minus y. So how are we going to form this in the form of y equal to fx? Most probably, no, cannot. So this is implicit function, and because of that, we differentiate this. We name this the differentiation of implicit function, where we differentiate of implicit function of y here. The implicit function of this, for example, here. So to find dy dx, differentiate each term with respect to the x. We apply the chain rule to differentiate a function of y with respect to the x. So in this case, because we are going to not just differentiate the unknown of x with respect to the x, but we also differentiate y with respect to the x. There's some addition here. For this subtopic, we can look at an example one by one. For this one here now, differentiate of y with respect to the x, and of course you come up with dy dx. And what about this one here now? We derive the function of 3y squared just like we derived the 3x squared. So just imagine that this y is an x, so if we derive 3y squared, you come up with 6y. But then because we derive this with respect to the x, then we come up with the term of dy dx. And what about this one here now? Derive e power of y is just like we derive e to the power of x, which is e to the power of y. Multiplied with, because we derive this with respect to the x, y here, so then come up with dy dx. Next one, derive ln, you come up with 1 over y. And when derive y, it gives you 1. And because we derive the y with respect to the x, then we multiply with dy dx. Next, in this case, we divide into two parts here, just like u and v. Look at this slowly. Differentiate x with respect to the x. We call u prime dot v plus u dot v prime. Differentiate x with respect to the x, 1. Then just copy out the y. Plus with, just now we derived the x, right? So it's now time for us to write down x, and it's turn for y. Now it's a turn of y now. So derive y equal to 1, and because we derive y with respect to the x, then we multiply with dy dx. Okay, now differentiate this, derive x, it gives you 1 u prime v minus u v prime divided by v squared. You still remember that? Okay, so x is we consider as a u and y as a v. So u prime differentiate x equal to 1, then y. Plus, then just now we differentiate x, derive the x. So now it's time for, we write down x and derive the y equal to 1. And because we derive the y respect to the x, then come up with dy dx. And everything divided by y squared. Okay. I found a mistake here. So it's supposedly u prime v minus u v prime, sorry. Okay. Supposedly that minus here. Okay. U prime v, okay, this is our u and this is our v. So for this one here, which is u prime dot v minus u dot v prime divided by v squared. Okay, so u prime, u equal to x, u prime multiplied with v minus u and differentiate v. Okay, v prime here differentiate y, 1 and dy dx divided by v squared, which is y, so then y squared here. Okay, now find dy dx in terms of x and y if this given here. Okay, so then the first solution here, 3x squared minus 2y squared equal to 6x minus 4y. Okay, so we derive left and right respect to the x, so d dx of 3x squared minus 2y squared equal to, and also here differentiate respect to the x, of 6x minus 4y. Okay, so we derive it one by one. Differentiate 3x squared equal to 6x minus differentiate of 2y squared equal to 2 times 2 equal to 4y. And because we derive y respect to the x, then we must come up with dy dx. Okay, then derive 6x equal to 6 minus and derive 4y equal to, derive 4y equal to 4, and because we differentiate y respect to the x, then we come out with dy dx. Okay, so you can see here now there are difference. 6x and 6, because we derive x respect to the x, so we don't have to write down a dy dx, but for this one here, we derive the y respect to the x, so we derive first 2 times 2 equal to 4y, then multiply with dy dx. Okay, so then we bring up, we call the term with dy dx, we put them on the left side here. So negative 4 dy dx bring up here become 4 minus 4y dy dx equal to 6, and 6x bring to the side become negative minus 6x. So then dy dx equal to 6 minus 6x divided by 4 minus 4y, and then take out, we call factorize between 6, 1 minus x, and then 4, 1 minus y, and divide by 2, each of these come up with 3 over 2. So equal to 3 over 2 times with 1 minus x divided by 1 minus y. Okay, so the next, oh, the question is there, sorry. Okay, now let's take a look at this one here. Okay, so then now first we differentiate the function left and right, e to the power of y multiplied with an x plus 2y equal to derivative of 3e power of 2x respect to the x. Okay, so let's take a look at the first part here. The first term, e power of y multiplied with an x. Okay, and in this case, we got two functions here, e power of y and then x. So we are going to multiply, we call just like y equal to u multiplied with v, so then y prime equal to u prime dot v plus u v prime. Okay, so then differentiate first here, e power of y, and it's just like differentiate e power of x equal to e to the power of x. So then e to the power of y dy dx, and then multiply with an x plus with e to the power of y and derive x respect to the x equal to 1 plus with, okay, derive 2y equal to 2 and then dy dx. Okay, then equal to derive 3e power of 2x respect to the x. So derive 2x equal to 2, 2 times 3 equal to 6e power of 2x. Okay, now the term with dy dx, we leave it on the left side, and the one without that dy dx we bring to the other side. So we call factorize this x e power of y plus 2 dy dx equal to 6e power of 2x minus e to the power of x. Okay, so look at this one here now. Class, I think that I don't realize I make some mistake here. Differentiate e power of y, e to the power of y, dy dx, and then multiply with an x. Okay, u prime with v, and then e power of y, then differentiate x equal to 1, e power of y. I don't realize that, sorry. Okay, so e to the power of y, and this is e to the power of y. Okay, sometimes I realize that there's a mistake here. So e power of y and e to the power of y. So x e power of y plus 2 dy dx equal to this one here now. Then dy dx equal to 6e power of 2x minus e to the power of y divided by x e power of y plus 2. Okay. Okay, quite complex, but actually that is easy. Okay, it's quite easy if you can follow the step one by one. Okay, now for this one here now, we come out with y squared equal to, okay, using the logs rule, log a multiplied with b equal to log a plus log b. Okay, so for this one here, come out with natural log of x plus natural log of y. Okay, so just imagine that, can we write this in the form of y equal to fx y squared. If we bring out log y to the left side, and it become y squared minus natural log of y equal to natural log of x. So how do we factorize until we get a single term of y equal to fx? Maybe not. Okay, so the best thing we can do here now is we just differentiate what we have here right now. So derive y squared equal to, then also derive in respect to the x on function of natural log of x plus natural log of y. Okay, so derive y squared to y. And because we derive y in respect to the x, then we come up with dy dx. Okay, differentiate ln x 1 over x, and derive ln y 1 over y, and derive y equal to 1, and because we derive y with respect to the x, then come out with dy dx. So we bring the term with dy dx to the left side, to y. So what we have here is 1 over y minus 1 over y dy dx equal to 1 over x, and then dy dx equal to, so then it becomes now 1 over x divided by 2y minus 1 over y. Okay, so simplify this into what we call dy dx equal to 1 over x multiplied with, okay, we simplify this first, it becomes, okay, now, oh, sorry, as recall, show this step one by one. It is 1 over x divided by, and for this one here we simplified as 2y squared minus 1 divided by y. So it can now become 1 over x multiplied with y divided by 2y squared minus 1. There you go. Okay, so example 3, differentiate every single of these respect to the x. Okay, so the key is we differentiate respect to the x. So that's why if we differentiate the function of y here, then come up with dy dx. Okay, now derive sine x multiplied with cos y equal to derive 2 respect to the x. Okay, so for this one here now, this is u and this is v. So differentiate this, it gives you u prime v plus u v prime. Okay, let's see slowly one by one. First, derive sine x. Derive sine equal to cos x, then just copy it all again, cos y, plus with, just now we derived sine x, it gives you cos x, so right now we copy it all again, sine x, and differentiate cos y, negative sine y, okay, and differentiate y give you 1, and because we derive y respect to the x, then come out with dy dx. Okay, so how can I say this? So this is our u and this is our v. So this we simplified as an u prime dot v plus u dot v prime. Okay, So differentiate of cos equal to negative sine y and dy dx. That's it. Okay. And differentiate of 2 respect to the x, a constant, equal to 0. So simplify this, cos x cos y. Negative minus sine x sine y dy dx equal to 0. So the term with dy dx will leave on the left side, and this will bring to the other side. So then negative sine x sine y dy dx equal to negative cos x cos y. Okay. So then dy dx equal to negative cos x cos y divided by negative sine x sine y. Negative divided by negative equal to positive. Cos x divided by sine x, cos over sine, cotangent x. Cos y divided by sine y equal to cotangent y. Okay. Now, this is a function, then we derive respect to the x, y sine x plus x equal to derive cos y respect to the x. Okay, so this we derive one by one. Let's just take one as a u and this is a v. So differentiate this term here, differentiate y equal to 1 multiplied with dy dx multiplied with sine x plus with, just now we derived the y, then come up with dy dx, then we copy out sine x. Now it's time for y, and differentiate sine, it gives you cos x. Okay, plus with differentiate x equal to 1, and differentiate cos equal to negative sine y, and because we differentiate y with respect to the x, then come out with dy dx. So now the term with dy dx we bring up to the left side, we put them all together on the left side, and the one with without dy dx we bring up to the other side. So then negative sign bring it here become positive, so sine x plus sine y factorize dy multiplied with dy dx equal to negative 1 minus y cos x. Okay, so then dy dx equal to negative 1 minus y cos x divided by sine x plus sine y. That's it. Okay, the next question here, y equal to 2 sine x. So take a ln on both sides of the equation. Okay, taking both the ln on both sides, so come out with natural log of y equal to natural log of 2 power of sine x equal to sine x multiplied with natural log of 2. Okay, so then differentiate both sides with respect to the x, differentiate respect to the x of natural log of y equal to differentiate of sine x multiplied with natural log of 2. Okay, natural log of 2 means it's a constant, there is no x or y here. Okay, so then differentiate this ln y equal to 1 over y. And because we differentiate y with respect to the x, then we come out with dy dx. Okay, now we take this so for this one, ln 2 is a constant. So differentiate ln 2 multiplied with sine x. So you come out with differentiate sine, it gives you natural log of 2, then differentiate sine cos x. Okay, so then dy dx equal to y, plus multiply y here, and then natural log of 2 cos x. Okay, and y equal to 2 sine x, so it's just like 2 sine x natural log of 2 cos x. There you go. Okay, so we have solved this question of solution of C here. So I do hope that you may try the question by yourself, and if you have a problem with any of these questions, so please refer to your during your lecture your tutorial session. Okay, so that's all for today. So the conclusion is, on this subtopic, we differentiate the function of implicit function with the we call the derivative of gy respect to we call differentiate multiplied with dy dx. So you may start begin your tutorial and try yourself, and good luck. That's all. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh, and have a nice day.